The next part of the chapter is called as nature of the roots. So for this quadratic equation, ax squared plus bx plus c equals 0, the solution or the roots is minus b plus or minus square root of b squared minus 4ac divided by 2a. So this is the solution. In this part of the solution, this part of the solution is what we call as the discriminant, the b squared minus 4ac part. And this discriminant is represented by the Greek alphabet delta, which is a triangle, just a triangle. Yeah. And then here we're going to predict whether the roots are going to be real or are they going to be imaginary by looking at the magnitude of the discriminant. So if the discriminant is less than 0, then the roots of the equation are conjugate complex numbers, meaning it's comprised of real and imaginary numbers. Moreover, it does not exist on the Cartesian plane. You can just write it as there are no real roots. The reasoning behind this is very simple. So we know that the square root of a negative number is undetermined. So therefore, when this becomes negative, there are no dual roots. The second part is if the delta or the discriminant is equal to 0, the roots are real and equal. The equal part I'll just explain right now. So if this becomes 0, then square root of 0 is 0. And plus or minus 0, it wouldn't really matter, like plus 0, minus 0. So therefore, the answer would just be minus b by 2a. So therefore, the roots would be real and equal. And by imaginary, I mean square root of minus 1. It's also represented by I. Okay, the third part is if the discriminant is greater than 0, then the roots are real and different. It's very important to be able to distinguish between the delta being equal to 0 and being greater than 0. If it's 0, then it's equal. If it's greater than 0, it's different. Like the two roots will be different. For example, let's take this. We have the equation 4x squared plus 5x plus 3 equal to 0. So here the discriminant would be b squared minus 4ac. It's 5 squared, which is 25, minus 4 into 4 into 3. 4 into 4 is 16. Into 3 would be 48. And when we calculate this, we get minus 23. So since the magnitude of the discriminant over here is negative, we can conclude that there are no real roots. Let's look at some key points that will be required for the next few topics we're going to do under quadratics. First of all, the graph of a quadratic equation is called as a parabola. The graph that we get, there's only two possibilities that we can get. Either it's upward facing or it's downward facing. This is how it's drawn. Like there are no other possible options. So this is called as a parabola or a quadratic function graph. So the next point is the point where the graph turns is called as the vertex, meaning the highest point over here and the lowest point over here is known as the vertex. So if the graph opens upwards, the vertex is minimum turning point, and therefore the graph will be concave upwards. So if you look at this value determines whether the graph is concave downwards or concave upwards. If this value is positive, then it's going to look something like this. It's going to be upward opening, also known as concave upwards, and the vertex will be the minimum point, because as we can clearly see, I'll draw a better graph here. As we can see, this is the bottom point. There is nothing below this, so therefore it would be the minimum point. So if A is less than 0, meaning it is negative, it will look something like this, and the vertex will be a maximum point. Okay, so the next point states that the vertical line that passes through the vertex is called the axis of symmetry. As this is very clear, the vertex, if you draw a line here, these two are supposed to be symmetrical. Something like this, even over here. And the next point states that the point where the graph crosses the y-axis is called as the Y-intercept. It's the point where x equals 0. For instance, if this is the graph, then this would be the y-intercept. And the point where the graph crosses the x-axis are called the x-intercepts, or they're also called as the roots of the equation. So now I will link the nature of the roots with this, with the graph. So if discriminant is greater than 0, the graph cuts the x-axis at exactly 2 points. There will be 2 x-intercepts, and if discriminant is equal to 0, then there will be one x-intercept, just one intercept, just one x-intercept. And if delta, or the discriminant, is less than 0, then the graph will not have any x-intercepts, and it will never cross the x-axis. Okay, so the next topic is the vertex form. As we previously discussed, the vertex of parabola is the point where the parabola crosses its axis of symmetry. It's also known as the turning point. And if the coefficient of the x squared term is positive, meaning a is greater than 0, the vertex would be the lowest point on the graph, and it would be concave upwards. And if the coefficient of the x squared term is negative, meaning a is less than 0, the vertex will be the highest point on the graph, and furthermore, it will be concave downwards. Okay, as we discussed in completing the square, this is how you can write it. It's also known as the vertex form, the a into x minus h whole square plus k, where h and k is the coordinate of the vertex, and the x coordinate is minus b by 2a, and y coordinate is minus of b squared minus 4ac whole divided by 2a. Okay, we know that the discriminant is b squared minus 4ac. So therefore, we could write the y coordinate of the vertex as minus delta, which is the discriminant divided by 4a. This is much more simple to remember. So this is, you can remember this. And let's just try a few things, a few equations. 5x squared plus 4x minus 9. Okay, so now we know that a is 5, b is 4, and c is minus 9. A is 5, b is 4, c equals minus 9. So the x coordinate will be minus b by 2a, which is minus 4 divided by 5 into 2, that's 10. that is minus 2 by 5. And the y coordinate would be minus delta divided by 4a. Over here, b squared minus 4ac equals 16 minus 4 into 5 into minus 9. That's 16 minus 20 into minus 9. 16 plus 180, that would be 196. And divided 196 minus 196, because it's minus the discriminant, divided by 4 into 5, and that will be minus 49 divided by 5. Yeah, that's the answer. Okay, so the x coordinate of the vertex would be minus b by 2a. So that would be minus of minus 16 divided by 2 into 9. So that would be 16 divided by 18. You could simplify it further to 8 by 9. Now let's find the coordinate of the vertex. It's minus discriminant divided by 4a. So that's minus of b squared over here is 16 squared. And 16 squared is 256. Minus 4 into AC divided by 4 into 9. So if we use the calculator to find that, that would be minus 112 divided by 4 into 9. And this would be minus 28 divided by 9. So this is the answer. The vertex would be 8, 9, minus 28 by 9. This is our final answer.